All right, I had somebody ask about problem 11. So problem 11, got a definite integral, and we need all that to equal pi over 24. A couple clues in here. It's not a pi in the answer, so I'm already thinking about trig. And if I look at the denominator, that looks kind of Pythagorean theorem-y to me. So when I start setting up my triangle, defining theta down there, whatever is being subtracted from is your hypotenuse, because c squared minus b squared equals a squared. And so I know that this has to be 1, and let's just make this 2x, because 2x squared would be 4x squared. And then the other piece of the triangle would be 1 minus 4x squared. C squared minus b squared equals a squared. So then what we need to do is figure out how we're going to substitute for the integrand and for dx. So let's set up sine of theta would be 2x over 1. And so then that means cosine theta d theta is 2 dx. And so I can just divide by 2 to get my substitution for dx, and that's great. The integrand itself is almost, what is it? Let's see. So cosine of theta is adjacent over hypotenuse. So 1 minus 4x squared over 1. That's the opposite of what we want. So I guess the opposite of cosine is, or the reciprocal of cosine, I mean, is secant. So secant of theta is the desired integrand. And then we're ready to set up our integral. And so our integral becomes secant of theta times dx. And dx is cosine of theta, d theta, over 2. Luckily, cosine and secant are reciprocal, so if you multiply secant times cosine, you get 1. So what we really just have is 1/2 times the integral of 1 d theta, which is equal to theta over 2. Theta over 2. A couple options. You can back substitute, or you can rewrite your bounds of integration in terms of theta. Because right now we're going to evaluate theta over 2 from x equals a to x equals 1/2. So let's just, let's just solve for theta. So if I know that sine of theta is 2x from over here on the left side, sine of theta is equal to 2x, I know that x is equal, I know that, I didn't want to write x is equal to, I wanted to write theta. I know that theta is equal to arc sine of 2x. And so to redo my bounds of integration here, I can have arc sine of 2a to arc sine of 1/2. So I have arc sine of 1/2 minus arc sine. 1/2, but it's times 2. So 1/2 times 2. In other words, just 1. And arc sine of 2a, and that gets multiplied all by 1/2. Okay. So the arc sine of 1, what angle gives a sine value of 1? The angle is 90 degrees, aka pi over 2. And then minus arc sine of 2a. Can't really do too much with that. All right, I'm going to clear the screen in a second and use the fact that we need to make this equal to pi over 24. So here's what we have. 1/2 times pi over 2 minus arc sine of 2a is equal to pi over 24. So I'm going to multiply both sides by 2. So I have pi over 2 to get rid of the 1/2 equals pi over 12. Then I'm going to subtract pi over 2. Pi over 2 is the same as 6 pi over 12. So I get the arc sine 2a is equal to 5 pi over 12 because I canceled out the negatives. And then 5 pi over 12 is just really not doing it for me. So I'm going to need to use a calculator here because that's not something I have memorized on the unit circle. The way we can cancel out arc sine is by doing the sine of both sides. So I do the sine of the left side and I do the sine of the right side. I'm going to grab a calculator here, make sure it's in radian mode. I'm going to go sine of 5 pi over 12. That gives me some big nasty decimal. So I have 2a equals 0.97 dividing by 2, giving me a equals 0.48. And that should be good.